Hi, and welcome to this flipped instructional session. This is Earth Science, Semester A. Today we're going to talk about Lesson 2.03, Minerals and Crystals, Part 2. And I am Mrs. Fessel. Your goal for this flipped lesson is to watch this recording before the Class Connect session. Then, look for the flipped follow-up on your schedule and attend the flipped follow-up to put this topic into practice. So one important thing to remember as we talk about identifying minerals is rarely can you identify a mineral by a single property. The properties we're going to talk about today need to be considered together to correctly identify a mineral. So the first thing we're going to talk about is physical versus chemical properties. So physical properties of a mineral can be observed without changing the chemical makeup of the substance. This would be things such as color, luster, streak, and hardness. The chemical properties of a mineral relate to the chemical nature and reactivity of the substance. To test chemical properties, you often need to change the chemical makeup of the mineral. So we're going to talk about examples of both of these properties today. So here are some physical properties that we're going to talk about today. So our first physical property is color. So color is one of the most easily observed properties, but the least reliable. That's because many minerals can change color depending on impurities within the mineral. So some examples of minerals that are always the same color are cinnabar, which is red, and malachite, which is always green. But as you can see in this slide, many minerals have the same color, so it's not always a reliable way to identify a mineral. Or, as I mentioned, many minerals can change color due to impurities, such as quartz. All four of these pictures below are quartz, but they are all different colors. Pure quartz is colorless or white, but the other ones that are shown down here have impurities in them that make them change color. Another physical property is luster. So luster is the way a mineral interacts with a light. Some, like pure quartz, are transparent. You can see right here the light shines through it. Other minerals are opaque, such as galena, which the light cannot shine through it. Other ways to describe luster are how the mineral reflects the light. For example, the quartz is shiny. You can see it reflecting the light. Many minerals have that shiny luster. Other ways to describe it is glassy, dull, or earthy. Scientists also use metallic versus non-metallic to describe luster. So here you can see a rock with a metallic luster, shiny, and this rock is non-metallic because it is not shiny. Our next property is streak. So streak is the color of the powder left behind on a streak plate, which is usually a hard white piece of tile, when a mineral is rubbed on it. So streak is more reliable because even though the color of a mineral may change, the streak will not change. An interesting thing is the streak is often not the same color as the mineral. As I said, the color of the mineral may vary, but the streak rarely will. Here's some examples. So here's hematite, which looks red, and another variety of hematite, which looks black, and they both have this reddish streak. Here is a brassy yellow mineral, but its streak is a gray-black. So streak is much more reliable than color in identifying minerals. Our next physical property is cleavage. So cleavage of a mineral is its tendency to split easily along flat surfaces. Cleavage can be observed even on tiny grains of the mineral if you see flat sides, which makes it a very useful property. So mica is a mineral that has a very obvious cleavage because it splits into thin sheets. It is said to have one directional perfect cleavage because it splits in one direction, which is thin sheets. Calcite and galena cleave in 3 directions. You can see here making these square shapes. So not all minerals show cleavage, which leads us to our next property, which is fracture. So those that do not break along clean surfaces have fracture. So there's no flat planes and no certain way that they break. So here's a circular or shell-like fracture. This mineral has a fibrous fracture. Sometimes it will just not break along clean lines. So that is the difference between fracture and cleavage. Cleavage, the mineral breaks along clean lines. Fracture, there are no certain breaking points. Our next physical property is hardness. So hardness is the resistance of a mineral to being scratched. The Mohs hardness scale, which we're going to talk about on the next slide, is one of the best tools for identifying the hardness of minerals. So on the Mohs hardness scale, common objects can be used to try to scratch the minerals to see how hard it is. For example, if you have a sample of calcite, you're going to be able to scratch it with your fingernail, but then the copper penny, opposite. You would not be able to scratch it with your fingernail, but you would be able to scratch it with a copper penny. That's because calcite is harder than your fingernail, but not as hard as a copper penny. Diamond is the hardest of all minerals, with a 10 on the hardness scale, if you noticed on the previous slide, while talc is one of the softest. So those are our physical properties, and now we're going to talk about some chemical properties of minerals. First would be an acid test. So calcite, which is made of calcium carbonate, if you put a drop of weak hydrochloric acid on it, it bubbles as carbon dioxide is released. It's a chemical property because carbon dioxide is being released and changing the chemical makeup of the mineral. Another chemical property is solubility. So some minerals dissolve in water, which is their solubility. For example, if you put crystal of halite, which is sodium chloride, commonly known as salt, perhaps sitting in your kitchen right now, the halite crystal will dissolve. Many other minerals will not. Another chemical property is a flame test. So this is pretty cool. When a small bit of mineral is held in a flame, the flame will burn a certain color. The flame's color is evidence that that particular metal is present. So you can see strontium, sodium, copper, all of these different minerals will burn different colors, giving us a good idea of what mineral is present. Okay, so I hope you enjoyed learning about physical and chemical properties of minerals. Your next steps will be to look for a flipped follow-up in your Class Connect schedule, to attend that live session to carry this topic into further practice through games, activities, and the teacher-graded assignment for this unit. Attend a Help Lab session if you need extra support, and as always, I hope you have fun learning. Have a great day.